Alright, so you're going to construct some.
Well,
not some, just one.
So I guess we can try, so we can kind of go off of this, and we can try to find triangles. If we want to keep them right, we can try to find triangles that are x plus 1, and then the square root of x squared plus x plus 1 squared.
Okay.
And try to find a triangle where these are all integers.
Alright, yeah, that's an interesting idea.
I guess you're not going to get this very accurate until you get large values of x. Because, I mean, the first triangle that comes to mind that actually does satisfy this is a 3, 4, 5.
Okay. Nice.
This isn't going to be close at all, but it does satisfy this, and his triangle is of this form as well.
Alright, well that's actually kind of a fun thing to notice. That his triangle, he did x plus 1, trying to keep it thing. And then we could search around for more. So we know there's at least 2. 3, 4, 5, and then this one.
137,903.
Alright, but since you found the 3, 4, 5, which we wouldn't normally be thinking of as one that was near isosceles, but it does meet this condition that we were looking for near isosceles. So what the heck? Let's see.
Alright, well, I guess we're going to have to do another law of... actually, we don't need to do law of cosines because we know cosine. I don't know which angle do we want to take. Let's take this one.
Alright.
So we know cosine theta is going to be 3/5.
Alright, this one we can probably do on the iPhone scientific calculator. Why don't I zoom in? Keep the calculator there. Alright, so how do you...
Is there an inverse cosine? Is he sine and cosine tangent? No. Oops.
Try the second button.
There we go. Okay, so I have to enter it first. So 3/5, and then
I probably have to evaluate it.
it's 0.6. Okay, there we go. So theta is about 53.1301.
Okay.
That's in radians. If I wanted to do degrees, we could do times. I think I messed something up. So 53.1301 times 180, and then divided by pi.
I think this is already in degrees.
Oh yeah. This is already in degrees.
Yes.
Okay, so how might we come to suspect that 53.13? We're not for sure.
Yeah, I mean it's a decimal point. Yeah. Okay.
No, but why might we think this was in degrees and not radians? Just kind of right off the bat, if we do arc cosine of 0.6. We don't know if the calculator's in radians or degrees, but when we do arc cosine of 0.6, it says 53.1301.
Well, it shouldn't be above 1 if it's in radians. Or at least it shouldn't be large. It shouldn't be this large if it's in radians.
Yeah, what should it... let's say we know this is an angle between 0 and 90 degrees. Right, so what should the radian value be?
So between 0 and pi over 2?
Right.
Well, yeah, okay.
Yeah, so we did have the problem when we did the other one off screen that the output was in radians, but we actually switched it to degrees, and so you wouldn't normally expect to see a number that was 53 radians.
Well, this isn't that close to 45, but we didn't expect it to be, so...
Okay. Alright, so I'm going to show you now the approach I did, and we're going to need to do about 1 minute of work also off screen before we start on this.